In the last lecture, we obtained the expressions of current gain, voltage gain and power gain. In this lecture, we will find out expressions of input impedance and output impedance. We will start with input impedance. Input impedance is represented by Z subscript I. The input impedance is defined as the impedance seen from terminals 1 and 1 prime. From Ohm's law, the input voltage Vi is equal to the input current I1 multiplied with the input impedance Zi. So Zi is simply equal to V1 divided by I1. Now I will use the H parameter equations, and from equation number 3 we have V1 equal to Hi I1 plus HR V2, and in place of V2 we can write minus I2 RL. So we have minus I2 RL in place of V2. Now I will divide both the sides by I1. We have V1 by I1 on the left hand side. Then we have HI minus HR I2 divided by I1 RL. I2 divided by I1 is equal to minus of AI. So we have V1 divided by I1 equal to HI plus HR AI RL, because current gain AI is the current gain and it is equal to minus of I2 divided by I1. We have already derived the expression of current gain AI, and I will put the expression of current AI in this equation. V1 by I1 is equal to Zi, the input impedance. Then we have HI plus HR inside the bracket minus HF divided by 1 plus HORL. This is the expression of current gain. On simplifying the right hand side, we have Zi equal to HI minus HR HF divided by 1 by RL plus HO. So this is the final expression of the input impedance, and this expression is true for all the 3 transistor configurations. The next part of this lecture is derivation of output impedance. The derivation of output impedance is little bit different as compared to the derivation of input impedance. The output impedance is the impedance seen from the terminals 2 and 2 prime, and to calculate the output impedance ZO, we need to short circuit the input source, that is Vs. We need to short circuit Vs, and we need to open circuit the output terminal. This means RL must be infinity and Vs must be 0. So these are the 2 conditions to calculate the output impedance. In examination, redraw this circuit for the output impedance. Output impedance. From Ohm's law, the output impedance is equal to the output voltage divided by the output current. So ZO is equal to V2, the output voltage, and the output current is I2. From H parameters equation, the output current is equal to HF I1 plus HOV2. So we have ZO equal to V2 divided by HF I1 plus HOV2, and let's say this is equation number 1. Now to find out the second equation, we will apply Kirchhoff's voltage law in the input loop. Vs is equal to 0, so KVL will give us minus of I1 RS minus I1 HI minus I1 HI. Then we have minus of HRV2 minus of HRV2 equal to 0, or we can write I1 Rs plus Hi plus HRV2 equal to 0, and from this equation we can obtain the value of input current I1, which is equal to minus of HRV2 divided by resistance Rs plus Hi. Hi is the input impedance parameter, and now we can put the value of I1 in this equation. Let's say this is equation number 2. So from equation number 1 and equation number 2, we have the output impedance. ZO equal to V2 divided by HF inside the bracket minus HRV2 divided by resistance Rs plus Hi plus HOV2. After simplification, the output impedance is equal to Rs plus Hi divided by HI minus HFHR plus HORS. And if you remember the last presentation, I told you HOHI minus HFHR is equal to delta H. So we can write ZO is equal to Rs plus Hi divided by delta H plus HORS. So this is the final expression of the output impedance, and this is all for this lecture. In the next lecture, we will derive the expressions for overall current gain and overall voltage gain.